All right, so let's look at the next piece of notes. And the next piece of notes has to do with work versus power. All right, so we're going to compare work and power in this set of notes. And one thing I always like to start off these notes is I want to tell you guys that actually what I have done years ago, and it wasn't too many years ago, it was only about 5 years ago, I actually lifted 20,000 pounds. That's what I lifted up, 20,000 pounds. All right, now you might look at that and go, you don't work out in the weight room. No, I don't work out in the weight room, but I did lift 20,000 pounds. All right, so keep that in mind because as we go through these notes, we're going to come back to that in a little bit. So, all right, well, so let's go to the notes and this whole idea of work. Well, work is force that's exerted over a distance. Okay, so it's force over distance is the definition for work. Now, the one really important piece to this is to know that in order to be truly work, and when I actually do work, I'm not talking about getting up and gotta go to work today. I'm not talking about that. I'm talking about scientific work and doing work on an object. If I accidentally drop my book on the floor, oh man, I gotta pick up my book. So I reach down and pick up my book. If I pick up the book, I'm exerting a force upward on the book in order to lift it up, correct? Well, what's the direction that the book is moving? Well, the book is going this way. It's going up also. So my force is up, my direction is up. Both of those are in the same direction. So I am doing work on the book when I lift the book up off the floor because the force is up and the direction is that direction also. Now what if after I do that, I'm tired of having picked this book up. So I'm gonna go take care of it and go put it on the shelf. So I'm gonna carry it over there and put it on the shelf. So in order to carry it, I gotta hold on to it. That means I'm exerting a force upward on that book. I'm going to carry the book that direction, so the motion of the book is that direction. So force is up, motion is that way. Are those in the same direction? No. So I'm not doing work on the book if my force is up and motion is that direction as I carry it across the room. Right? So an important piece to know on this whole idea of work is that it's got to be in the same direction. The force has got to be in one direction, and the motion's got to be in the same direction to be classified as work. All right. Now we can join the equations together on this. There's a couple of them that we've had so far. We've had where work equals force times distance. Whoops. Actually, it shouldn't be a big D, it should be a little d. So force times distance. Well, earlier in a previous chapter, we had force equals mass times acceleration. So we can actually take this F and put it in here. It's like, well, that doesn't make any difference. Well, what our idea is we really take this because F is equal to M times A. So I can pull this F out of here and put M times A in there. I can get force equals mass times acceleration times distance, and that will give me the work that is being done. Right? So that's another way of rewriting this formula for work. Right? Is that it can be work equals mass times acceleration times distance. Right? All right, so let's say we're going to go on a hike, and we're going to go up a hill. So we're going to go up this hill right here, and we're going to go up here and see if we can't capture this flag up here at the top. There's a flag up on the top. We want to get to that flag. So we got two different directions we can go. All right, one direction we can do is we can start here at the bottom, and we can go straight up to the flag, right, all the way to the top, just straight up the side of the hill. Okay, so that's one direction we can go. The other option we can do, and I'll do this in red, is we can zigzag. We can go over here, and then we can go over there, and then over here, and then over there, and there, and there, and there, and there, there, and there, and there, and there, and get up there that way, back and forth. All right, so those are my two ways that we could get to the top. So the green one, the one that went straight up, all right, I'm going to have a really high force in order to go straight up. It's going to take a lot of force to climb that mountain going straight up. All right, so we can give that, let's give that a number that's going to be like a 10 on force trying to get straight up on that hill. But my distance is going to be really small. So we're going to give that a distance of 1 because it's going to be a really short distance when we compare it to the other option. All right, so now if we look at the red one, going back and forth, notice this angle, that's not very much slope there. That's pretty small. So I'm going to have a really low force that I have to exert on this. I'm not even going to notice really that I'm walking uphill because it's just this really slight slope. So I'm going to give that a 1. All right, but notice the distance. Oh my goodness, I got to walk here, walk there, walk there, walk there, walk. Oh my gosh, I got a really long distance. So we're going to give that a 10. That's a lot of distance. right? So now if we look at this and go, okay, well, which way takes more work? Commonly, a lot of people go, oh yeah, it's going to be going straight up. That takes a lot of work. Go straight up. Ooh, man, that's a lot of work. Not by definition, not by scientific definition. Reality is, whether you go zigzag, or whether you go straight up, it's the same amount of work. Serious? No way. Yep. Because really remember that work equals force times distance. So on this side, if we go zigzag, I really got force is 1, distance is 10. So 1 times 10, that's 10. And if I go this other way, going straight up, I really have a force of 10, distance of 1, 10 times 1, that's 10. So my work, either direction, is the same amount overall, right? So, all right, so if I go straight up, the one thing is going to take a lot of force, but it's a short distance. If I zigzag, I don't have to exert very much force, but it's going to take a long distance, right? So they're exactly the same amount of work. All right, so according to that same amount of work, straight up is more force, but short distance. And in your notes, you might want to draw this in your notes. I left a little blank there for you to draw that in there. That's why it's a blank spot, right? Zigzag is less force, but long distance. So why then does zigzag feel easier, according to the notes? Why? Because you exert a lower amount of force, right? It doesn't take as much force going up this little incline. Right? Kind of like out in the hallways in the school. Have you ever noticed that? We got all these ramps that go up. Why do we put ramps? Because it doesn't take very much force to go up there. You don't really notice that you're going up a ramp to get to the top of the hill, right? If we put steps there, then you have to come up to it and you have to climb the steps and exert a whole bunch of force on each one of those steps to get up, right? But that's why we put the ramps in the hallways, to make it what would feel easier to go up the slopes, because they're spread out over a long distance and you don't feel how much force you're having to put in it because it's very small, right? So again, it says think about the ramps and the stairs in the high school hallways, right? So that's why we put those in there. All right, ramps are easier because less force over a longer distance. Stairs are harder because there's more force over a shorter distance. But they are actually exactly the same amount of work, whether you go up the ramp or whether you go up the steps, right? Oh, now let's get to power. I told you I can lift, and I have lifted 20,000 pounds. Actually, even right there in the notes, it says Mr. Pape has lifted 20,000 pounds. That's a lot. That's way a lot. That's like 10 average size cars. I've lifted 10 average size cars. And now you're going, ain't no way. Yep. How can this be? Well, actually what I did is I lifted 100 pounds at a time, 200 times. And if you do that, what it is, that's 20,000 pounds. What I did is I had some corn that I had to move from one place to another on my farm. I couldn't use any kind of motor to do it, so I just grabbed a couple buckets, filled up the buckets, carried them over and dumped them, and then filled them up again, carried them over and dumped them, filled them up again, carried them over and dumped them. And each time I filled the 2 buckets, that was 100 pounds. And I did 200 trips back and forth. And it took me about a half an hour. And in a half an hour, I picked up 20,000 pounds. Right. Now I do it, I used to. I don't have any more, but it finally got too old and wouldn't work anymore. But I used to have a dump truck. That dump truck could lift the whole 20,000 pounds by itself too. All right. The dump truck did it all at once. I pressed a button on it and the thing went and dumped all 20,000 pounds. Which thing did more work, the dump truck or me? Right now you're probably going with the dump truck. The dump truck lifted 20,000 pounds, but so did I. I lifted 20,000 pounds. It's this thing back here. We did exactly the same amount of work, right? This one over here, the slope thing like this, that's me. I exerted a really small amount of force and did a long distance walking back and forth 200 times. Dump truck, it exerts a really big force, short amount of distance. It just goes, dumps it. Right? We do exactly the same amount of work. So all of a sudden, if we want to look at it and go, well, the dump truck seems like it does more work, doesn't it? Then we got to add something else into it. Who can do it faster? Well, the dump truck can do it faster. I press that button, it goes, and in less than 30 seconds, all my corn is on the ground. For me, dumping 20,000 pounds, it took me a half an hour, right? So what is that? Well, that's a thing called power. And when we talk about power, we have to add in time, Okay, so we really take the amount of work and divide that by time. And when you do that, then that actually gives you power. So my dump truck is more powerful than me because it can do it in a shorter amount of time. It can do it faster. Okay, but again, every single one of us, and I use myself, but really every single one of us, all of us in this classroom, we can all lift 20,000 pounds. We just have to do it in little bitty increments, maybe 50 pounds at a time, 20 pounds at a time, 5 pounds at a time. It's going to take a while, but you can lift 20,000 pounds. Okay. Well, that concludes our notes. Even lights just turned off even. So that's the end of today's notes. Have a good day. We'll see you.